So I'm gonna do a little presentation of what I've been working on, doing some event-driven audio, just trying to play certain audio files uh, at various places based on events sent from maybe somewhere else. All right, and it's just gonna be some simple, relatively simple apps using Spring Boot and using RabbitMQ. Alright, first of all, we're going to need to make sure you've got RabbitMQ either installed or a Docker image. I've got a Docker image config and JDK 11 plus. Earlier versions may work, but uh, I'm most comfortable using 11 plus because it's got all the neat new features. Okay. Let's see, Rabbit config. Here's the if you've got Docker installed and you don't want to bother with Rabbit installation on your system, your package manager or whatever, this is a pretty darn easy way to set it up. You can just do docker-compose-f this file containing this contents, up-d, I like -d, puts it in daemon or background mode. You don't need that if you want it putting its logs on the console, which is useful sometimes, but I don't care in this case. What's important here, you can give it whatever name. Image RabbitMQ:3. 3-management also allows the web interface, which is going to be nice to look at the messages we're going to be watching pass through. And environment, these are a couple of neat environment variables. They've the packagers of this image have allowed to configure automatically at startup the username and password of the default admin user. So that's kind of useful stuff. So you can just run that and go to 15672 on your local host, and you can actually just log in with that and get access to all the nice goodness. Let's see, and JDK SDK man, I'll recommend SDK man if you don't want to bother with your normal package manager way of installing the JDK, or heaven forbid going to an actual website, Sun, Oracle rather, and actually downloading it. I'll give a little plug for SDK man. It's pretty easy to to get it started. They've got a convenient install straight from the website. Probably don't do this usually, but I've had good luck with them so long as we trust their cert and trust that they're gonna not get hijacked. And let's see, what does it look like? SDK. I've got an alias to SDK, and it lets you SDK install for a particular software package. It supports more than just Java, but SDK Java install a particular version, and then SDK install or SDK Java use or default that version. So it's got convenient listing functionality too. So I don't want to spend too much time on it, but it's a convenient way to get your Java installed. Okay. I also am using IntelliJ here. It is possible to run this without IntelliJ because it's just using bundled Gradle. I like IntelliJ. Even the community version is it should be fine to use for viewing this and importing these projects. But I'll now move on to the three relevant repositories I've got here. Event audio I've developed as an SDK and later regretted my decision to split it out into a separate repository, but oh well, that's the way I did it. So I would force myself to learn how to deal with artifacts generated from separate repositories. And then there's an audio player that's going to listen on a queue, on an exchange. And there is an audio submission app, which is going to allow you to submit requests, submit audio play requests. Okay, so going into the event audio SDK, it's going to define the event model. So we want to make sure everybody who's talking, client or consumer, is going to understand the same messages, at least a basic structure of them. And this also, in this project, I also defined a client that knows how to submit a play event request onto the configured audio queue. Right. Event audio. Here we go. All right. So I said I was going to talk about the play event. All right. So this is pretty simple. I'm using Lombok here. If you don't know about it and you're using Java, you should learn, and then you'll be happy. It takes away, it allows you to use simple annotations to automatically generate a bunch of boilerplate stuff. So this data means for each of the fields in here, it's going to generate a setter and a getter automatically. So you don't have to worry about that. Let's see, and builder gives a nice fluent builder interface if you, for some reason, want to use that instead of always using literal constructors, which is, it's actually, I prefer using a builder 90% of the time now, because if you add a new field and you've used literal constructors everywhere, it's a real pain. You have to go, refactor, add the new field, assuming it's required, to every instance of your constructor usage. If not, if you're using a builder though, well, if it's a new required field, then yeah, you probably do still need to go edit it, but you can just add the required field, and it's real easy, convenient syntax. I'll do something evil here. Play event. And boom, we've got one of these, but you can file path, x dot leave dot duration 2s. So it's got these. I'm wanting to add samples. It's got these convenient just property name methods that mean, okay, give the builder this value, and then when it's done, it'll populate the appropriate constructor fields with that value. So it's no more of this. Which position was this again? Was the UUID versus the file path? Did they get flipped around in some constructor or not? No reason to worry about that. It's just a real convenient syntax. Anyway, so I'll undo everything now. So yeah, Lombok, that's pretty cool. All right, here's the basic structure of the play event. It's got a UUID because maybe we'll want to track flow of a particular event all the way through, from when it was submitted to when it gets played. File path of the file that should be played, and duration note, I actually don't even use this, but in a potential future version, we could actually use that if we wanted to play, you know, play only 2 seconds of something or something. Or maybe even support looping if you've got a 2-second audio file, but you want it to play 4 times, specified duration 8 seconds. That's something we could consider for the future. I just left it in there. Okay, let's see. That's the event model. Let's see, queue client. I don't want to spend too much time in here, but basically, this takes a play event and submits it to the queue. It has some configuration information, kind of constructor injected into it. It's a component. It's a Spring component, which means it's going to create a bean that's also going to try to automatically resolve its let's see, with this auto-wired annotation. That means it's going to use this constructor and search for other beans or property beans to fulfill these dependencies, inject them, create in the constructor, and then this will be registered as its own bean, which is just an in-memory particular instance of a class that is ready for injection elsewhere. It knows how to submit using that configuration information. It'll publish a version of, it'll publish a JSONification of the event onto the target exchange using the target routing key. No properties, and here's the payload. That's just JSONification right there. And it handles some stuff, some exceptions. It's also got a setup method, but that we don't use that. I just extracted this stuff out of here, declaring an exchange, declaring a queue, and binding that exchange to the queue, or vice versa. That's stuff I used to have in the submit. They would try to bind it every time. Turns out that's a problem, and especially a problem if it's not exactly the same way. Like one app configured it one way and one app configured it another way. It got to be a problem. But it's here as a convenience method if your application for some reason needs to be in control and assure that it's got a particular queue setup and binding setup. But anyway, this is the main method we use. This is just I've got this event, throw it onto the queue. All right. All right, and so because this is an SDK, this is going to generate an artifact that is going to be used in other projects, in other repositories. I don't have my own artifactory set up or anything like that, and I certainly am not publishing this to any public repository like Maven Central. So how am I to share this artifact? I don't want to manage. I don't want to go look for the jar and manage it in every single project. There's the convenient publish to Maven local script task that's available in Gradle. So if we go to build.gradle, is this it? No, this is, I meant to look at the root one. You know what? It doesn't matter in this case, actually. No, here it is, Maven publication. You do have to have a specification for your for how what items to publish, and this is, I guess, fairly standard. Honestly, Gradle is fairly arcane, but it's also very powerful and convenient most of the time. So you just kind of learn to work with it and understand its quirks. Groovy would be a good language to understand. But this basically says, okay, when I want to publish to Maven local, well, any Maven, these are the this is the artifact ID I'm going to publish as is the project's name, and the things I'm going to publish are going to come from project.components.java, basically all of the components. Anything that's a component here is going to get published. Okay, and then we execute publish from Maven local, and hey, it succeeded. Did it tell us where it ended up? No, but how about find /.m2/repository -mmin -3 stuff that was created less than 3 minutes ago. Hey, look, here's my jar. Kanji Soup Audio Event SDK is the name of the project, and thus the name of the module. Version, I just recently bumped from 0.02 to 0.10 because I made an incompatible change. And honestly, I should have bumped to the major version, but I was working with the 3rd level down already, so whatever. Yeah, Semver is not whatever, but given that this is still a very relatively private and kind of beta project, I figured it's not that bad that I'm kind of breaking Semver. I'm not breaking the spirit of Semver, but I'm certain breaking the exact rules of Semver. Okay. So anyway, it got published there. So that's what publish from Maven local does, which I had to use for this project. And it should behave the same on your machine as on mine, given that the actual invocation is Gradle W /Gradle W, because there's a built-in Gradle wrapper committed to this project. Publish to Maven local, and assuming you have a compatible version of the JDK installed and configured and all of that, it should be able to do the same thing on your machine. Okay. Right. Good. I did a good glossing over build.gradle. Good note. All right. All right. Well, now let's move on to the audio player, because we've got that. We've got the original base SDK kind of covered. All right. Audio player itself. Let's check out what this thing is. Okay, so this is a component. I put it into its own SDK module inside of the audio player project. It's got a base path. It has a constructor with its own audio player config, and that comes from configuration properties. These are going to get populated from application.yaml. Anything directly under the prefix com.conjusoup.audio.player that matches the name baster or base-dir. Hey, look, here it is. com.conjusoup.audio player baster. This is going to be what's used to populate the value of this when Spring starts up and initializes its beans and property beans. And then it'll get injected into here as a dependency of this audio player, and it'll use that to determine the base path. So this base path is going to be the root directory from which it serves its pardon my switching. From which it plays audio files. So it's not going to play any audio files anywhere else. It'll only play audio files from within that directory or subdirectories. So this one's ready to listen for a play event. It doesn't do the listening, that's another component, but this is ready to give in a play event. that somebody passes it, it is ready to go ahead and attempt to play that. Let's see. It's going to resolve file, make sure it can actually find the file, and then this is kind of some stolen code, and it's a little bit weird. There's probably a better way to do this, but this is the way I found to do it. Just treat it as an audio input stream. Let's see, and tell a new audio system clip to open that input stream and start. And this is dependent on the application remaining open, but thankfully, since this is going to be a listening service, it's going to remain open. And my understanding is that this audio playing actually happens in another thread. I don't know for sure about that, but I do know that if the application stops, so does the playing. It doesn't start in another process that's unrelated. It actually is tied at least to this process, but maybe not on the same thread. Well, heck, I don't see how it could be in the same thread, given that it does continue on and multiple audio files can be played at once. So there's my answer, isn't it? All right. All right. Next item. Consumer. All right. So I mentioned how this guy knew how to play an audio file, but it doesn't do the listening itself. That's why we've got a consumer. So a consumer implements message listener. This is a Spring MQP. Let's see, what is it? Asynchronous message queuing protocol or advanced? I'm not sure what the A stands for exactly, but that'll be a fairly easy thing to go check. Anyway, AMQP is pretty common acronym for queuing. All right, so this is an interface that you can implement in order to be ready to be registered to listen and respond to messages. What's a message? Well, it's just it's a wrapper around the content. It's got some properties that may be automatically populated or may be explicitly populated by the sender. We didn't send any explicit properties, but some happen automatically. And it has a body, which is what we care about. Take the JSON, we'll translate it into a play event using JSON. JSON's pretty smart, knows how to translate simple JSON into simple classes, so we're good there. And then we'll have our audio player. Oh, I forgot to mention, yes, this takes in an audio player. So we've got a couple layers deep here. We've got our audio player component, which takes in some properties, and in turn that audio player is used by this audio queue consumer in the same way. And hey, it's also components. We'll get into that later, how it's used. So whenever it gets a message, whatever is telling it when it gets a message, this happens. It's gonna play the audio file. So that's a little bit of abstraction there, but I like tidying it up rather than just doing all the logic inside of this consumer itself. Let's see, where was I? Config. Alright, we already went through the config. Yeah, there are a few exception scenarios, but I won't spend any time on them. Alright, now let's go into the app. That's the other module here. So, player application, Spring Boot application, it's going to scan for base packages starting with com.conjusoup.config. This is basically what your basic Spring Boot application is going to look like, the point of invocation, the app itself, which is going to look like, okay, what do I care? This is telling me nothing. Well, it's a starting point. Common config soup config. What's underneath that class? There's a config class with a configuration annotation, so it's going to get scanned. And it's going to do a component scan for anything that's got anything underneath config soup audio player, which includes these guys, which wouldn't happen unless we had this dependency. This is how you express a dependency on another module in the same project. Use parentheses and colon, and then module name. All right, so that pulls in this from a compilation standpoint and class path standpoint, and this means, okay, now that we've got those classes, go check for any of them that need to be initialized, turned into beans. The ones with the component annotation on them. This one, and this one also gets loaded because it's been configuration properties loaded. Enable configuration properties is one of the other major annotations for configuring your application. And here, look, this points specifically to that class. There's also another one, and this is other queue configuration, which is used in the SDK. Of course, this app doesn't use the SDK for its submission properties. It actually uses it only for for bootstrapping itself, for creating beans. Okay, which is back in this file, back in the application config. So this is where all the bootstrapping happens, pretty much. So in addition to all the automatically scanned components, this is also going to explicitly create some more beans, configured literally by code. So this is going to get kind of boring, so I won't take too much longer here. But basically, a lot of these arguments are going to get shared. These ones are going to get reused. It's fine to pass it in multiple places, and this is going to end up creating an exchange, a queue, and a binding between that exchange and queue. And here's the important one. It's going to create the listener container, which is basically how it binds the exchange and queue to actually listening for messages on that queue, and then telling our particular little consumer. Here's our audio queue consumer passed in. That came as a component because we loaded it from down here. Saying, all right, whenever I get a message, I'm going to pass it on to this guy. And then we get to let our little consumer do all our dirty work of playing the audio file, except it passes that on to the audio player, which does the actual playing, and uses this stolen code. All right. Cool. So that's and then the application just runs. It listens using this information to make the binding and listen. And let's see what else we got in here. Application name is pretty standard. Okay, and then this is a special configuration that allows us to let it run, but not start up the whole web app, which makes it start up a lot faster. Because it really doesn't need to export any web routes, it's just a listener on a queue. Okay, cool. We're done. Done examining the audio player app for now. Now let's, actually, you know what, one more thing. Running it. Okay, so I have it using an additional application .yaml file, spring.config.additional location, and then path to there. Let's look at that application 3. Okay, I repeat myself here also. Oh no, this is required. Spring RabbitMQ, and then the username and password are generally required. Actually, if you didn't make any changes to your back when we, let's see, where did I put that? No, that's not it. Back when we created our container for RabbitMQ, if you just left it all default, you don't even need all this. But since I changed the username and password, I need to override those. There's a bunch of other configuration parameters there, but these are the only ones we need to deal with. If you did other stuff, or if you're configuring this for use in, you know, a somewhat production-ish or pre-production-ish, you know, anywhere other than your local machine, then yeah, you'd want to be familiar with how to use these. But this is all we care about. All right, and I use the same fan-out exchange type, but I create a new queue and make a binding from the event audio exchange to the EA3 queue, which is just going to make these events go to this queue also. Why? It doesn't matter, because I'm only going to demonstrate running one at a time right now. It could matter if you were running several. But that's a lesson in how queuing systems work, how RabbitMQ works. Also got some logging stuff here. I won't go into it, but it's a way to configure logging. I have written logging into here, so through use of SLF4J, which I believe is also from Lombok. Yeah, SLF4J. It's just a quick way to throw in a logger configured, configurable and backendable by several different logging implementations. I like Logback right now, but anyway, it'll give you a logger, and you can log to it, and you can ignore it, or you can configure your logging implementation. So that's another good thing to follow. Might as well include logging. Let's see. Right, now we're moving on to audio submission. This is part 3. For those who are following along, this is part 3 for those who are not following along also. Okay. What did I want to talk about here? Audio submission. Config, sure. Alright, so audio submission, by default, I'm going to have it run on port 8080. That's the way you configure a Spring Boot application, telling it what port to run on. This is, of course, relevant to this application because it exports REST paths. Let's see. Autopiece. Okay, we've got basically our same queue configuration here. Oh, I will call out this notation is kind of nice when you want something to be the same as something else, whatever it happens to be. This routing key, com.conjsoup.audio.queue.routing key. You can in Spring app YAML. I think other application properties implementations, but definitely at least application.yaml. You can reference other properties like this. So that's a nice thing, is I can just let that match by default. If you change your routing key in your local properties and then don't touch queue name, it'll still match up. Well, that's kind of nice. All right, let's talk about our beanings. All right. Oh, what happened here? Okay. All right, we've got submission application config. It's going to use that client that we saw in the initial event audio SDK, as it were, and it's going to also load in anything from .audio.submission. It's going to load in configuration properties, and it's also going to load in connection configuration properties. Actually, it doesn't need this anymore. We'll ignore that. This was, I had done this for Spring RabbitMQ to use the same set of Spring RabbitMQ properties because I had to configure my own connection factory because I was using 2 different libraries that had connection factories named the same thing, and they behaved in almost the same way, but they just weren't compatible. But I wanted to still leverage the configuration, not have 2 separate places to configure the same darn pieces of information. But anyway, I digress. That was just a holdover. I'll fix that later. It's no longer needed because we're now using one that Spring loads. Okay, configuration properties. Okay, application compound soup config. Load this. Okay, dot submission. And so that's going to be the controller is a REST controller, which is also a controller, which is also a component. So it'll behave in basically exactly the same way. It's still going to be a bean. Important things about this are its request mapping. That's the root of all of its requests handled within this controller. So localhost 8080 or 8081 / event audio / and then individual further mappings are handled here. So post mapping, so post to submit. It's got some documentation, and this is going to trigger this method. You pass it a JSON object containing a file name, something like this. And wow, this really does have the worst ordering of tab closing. Okay. All right, and it'll trigger this method. It'll build a new play event because this is a different thing from the event model. This is a request model. Okay, but it'll build an event, a play event around it, and then submit it using its audio queue client. Oh, hey, yeah, that's right. It had one of these injected, but that came from our other dependency, and I was able to add that in because where'd it go? Oh yeah, I'm literally right on it. So I'm able to pull this from a Maven repository or Maven compatible repository that it knows how to find. It knows how to find it because I have added Maven local into here. It's going to look on Maven Local if it can't find it on Maven Central, and it's definitely not going to find this on Maven Central. Okay. It's got some other dependencies in here that are standard to pretty much all my projects, and then relevant to being a Spring application that uses RabbitMQ. And I won't explain these in this right now, because they were just results of hours of frustration, all these plugins. Okay, so our audio queue client was automatically loaded because we had it available because of our application config component scan included it. It was inside of this package, and it's included in the build. So there we have it as a dependency. Okay, beans and binding. Okay, so it actually uses the client entirely. So all of the, here, I'll go back to it just to show. Client takes in a connection factory. But Bob, where's our connection factory coming from? Well, this is the Spring MQP connection factory now. You see the com.RabbitMQ or .RabbitMQ. Anyway, I changed it over recently so we can actually leverage all the default Spring.RabbitMQ. I realize I'm looking at the wrong YAML file. But Spring. Yeah, there it is. Spring.RabbitMQ. This is going to generate through Spring's automatic internal configuration and property loading, and then therefore bean loading. It's going to use these properties to generate its own connection factory, which is then able to be used as the dependency to inject here. And then we get a nice client that is able to listen to our requests when we ask it to submit audio, when this controller listens to actual requests from the web. So that's the basics. Yeah, I just pasted these up here, but I just also went into them on my console. So yeah, in this example, I'm using name, user, and word pass. You'll go name, user, word pass. Okay, get back to where we are, and now it's running, because I already ran it. But if we want to go into the configuration, I'm running this application, passing in additional location, Spring config additional location of my submitter application.yaml, which is basically this, all this whole file. And I've already run it, so let's see, have I shown you running the audio player? I am running the audio player using application tree.yaml, and it's just keeping on checking its queue. It hasn't played anything yet. Well, okay. Now I'm going to go ahead and play this file. Okay. Oh god, it's my voice. Well, anyway, and just for completeness sake, it's got by default it is looking in that. There we go. Let me find the application.yaml. By default, it's player config, right, is configured to look in my home directory under a directory called audio player as a base file path, and that directory has a file in it called ocoyote.wave. So if I type in here good morning.wave, that's another file in here.
Good morning.
All right, and then flute sample2.wave. Flute sample2.wave. Okay, that's a silly little flute. Okay. If I do flute sample.wave, now that's a symlink to somewhere else. I found it in another directory. I made a symlink to it. It's not going to play that. Now, the submitter app thinks it's a success. But if we go look at the player app, oh, that's an exception. Invalid file request. That's actually a security feature I added in because we actually resolve the canonical path of the file's canonical path should be strictly underneath the base configured path. And since this is a symlink to somewhere else, this is the canonical version, which is not under home myself audio player. It's under this other path. So it's going to reject that out of hand. That's not a valid audio file to play. So that's also going to prevent me from doing shenanigans like, hey, you try to play this audio file. You can play that, right? Well, submitter application, once again, is not doing anything fancy to validate, but look here, invalid file request, because guess what? Once again, it doesn't start with the same canonical path. So that's going to prevent us from doing the silly shenanigans trying to get me to play the audio file of your password file or your shadow file, and listen real carefully to what the bits must have been. So yeah, that's hooking it all together. So if you've got any questions, feel free to contact me. I'll put my slides up. The code is out there. And I'll see if I can find a way to get good configuration out there. I've got some up already on the wikis. Let's see. Audio player application. Nope. This isn't the one. Audio submission. Is this the one? Here we go. Okay, audio player application. I've got a little bit improved documentation for kind of how to bootstrap yourself in terms of configuration. And then there's a little bit of fun you can have with configuring the queue differently. You have five audio players, some of which are on different queues or not. If you're using fan out, it should go to all of them. But there's different exchange types to control different event propagation behavior. Anyway, so that's all the news from Lake Wobegon. I hope you've enjoyed this, and I hope you have fun. All right, take care. That's not what I meant to press.